Victor Moshonchuk, and today I'm going to be reviewing the 2008 AP Calculus AB for response question 1. So the question goes as follows. Let R be the region bounded by the graphs of y equals sine pi x and y equals x cubed minus 4x as shown in the figure above. So let's start off with A, find the area of R. So we're going to find the area of this whole graph right here, and we have these two to start off with, right? And we should know to find the area when there's two different functions. We will typically do top minus bottom to find the area. And a very helpful thing for this would be to know, a very helpful tool to have is to know the parent graphs of sine, cosine. These things are well to know in general, but for this particular one, we know that sine looks like so. And if we look at the calculator, there is the sine graph. So we can tell from the looking at this and the calculator, we can tell that this, which is the top, is the sine. So therefore we'll be doing the sine minus the x cubed minus 4x. So let's write that out. Do integral sine pi of x minus x cubed minus 4x dx. Now you might be saying, what about the limits? Now, another very useful tool is to find intersecting points. We would have to do something like sine pi of x and set it equal to x cubed minus 4x. And this would give us our two limits, but looking at the graph, we can tell they intersect here at 0 and here at 2. You won't be always as fortunate, but in this case we are. So we know that x equals 0 and x equals 2. Therefore, in our integral, we'll be going from 0 to 2. And now, using our skills of the calculator, you're going to have to pull out another one of your useful skills that we have, and that is to use the integral to solve this equation. So we go math on the TI, we go to math, go to integral, we go from 0 to 2, and I'll be right back with the full equation written out because it's going to take a while. Alrighty, so here we go. Sine, we have to use a lot of parentheses to make sure we don't make any errors. Sine pi of x minus x cubed minus 4x dx. As I said earlier, it's top minus bottom. Sine pi x top minus x cubed minus 4 to the bottom. Let's see what we get. And surely we get 4, which is the correct answer. Very simple. Equals 4. And for this question, you get not this question, but this particular section of the question is worth 3 points. 1 for finding the limits, 1 for the integrand, and 1 for the answer, equaling a total of 3 points. Now let's move on to section B. The question says, the horizontal line y equals 2, negative 2, splits the region R into two parts. Write, but do not evaluate an integral expression for the area of the part of R that is below this horizontal line. So I already have that horizontal line drawn out. And top minus bottom, right? So we're going to same concept here. And like I said earlier, we had 2 and 0. This time we're not so fortunate, and we're going to have to find these two intersection points. But like I said, like a skill that we need to know how to have, I will set it up and be right back. Alrighty, so what you want to do is click on your y equals right here, and you want to set up negative 2 as y1 and y2 x cubed minus 4x. So you have two different lines, and we'll go to zoom fit. Surely there's a horizontal. There is our other. And we want to go to where the lines meet up. Alright, so right there, you see where it meets up. So let's see if we can focus. So our x is going to equals 0.55319, blah blah blah. Alright, let's move down to our endpoint, our right endpoint. So 1.68. Alrighty, so we have our two x's. I'm sure that'll equal something, right? So if we were not fortunate enough to use a calculator, we would have to set those equal to each other. So let's just, so it would be -2 equals x cubed minus 4x. And like I said, x equals 0.168 and x equals 0.5532. Alrighty, so we have our limits. And let's get ready to set up our integral, which we do not have to solve, thankfully. So just like I said earlier, same thing as last time. We're going to set up our integral as, say, b to a -2 minus x cubed minus 4x dx. And this question is going to be worth 2 points for finding the limits and having the integrand. Let's move on to section C, where we have the problem stating the region. Hold on a sec. Alright, the region R is the base of a solid. For this solid, each cross section perpendicular to the x-axis is square. Find the volume of this solid. So square, that's a very big clue that we have, in that a square, the area of a square is one side squared, right? And so same thing, we have 2 to 0. We have top minus bottom, sine pi of x minus x cubed minus 4x. We'll just do this, and the whole thing is squared, dx. Let's put that into the calculator. Bring it down here. Math. Integral. Let's set it up to, actually I might even do this. Just redo this. Oops, that's definitely not right. Just take this one. Just have everything squared. If you guys were ever wondering, there's a pretty handy dandy button. You just press second and delete, which will basically be insert. We'll insert a parenthesis. And then we will put another parenthesis and just square the whole thing. Square the whole thing. Alright, and that gives us 9.978, which is the correct answer. Alright, let's write that down. This equals 9.978. Alright, and that section is also worth 2 points for the integrand and the correct answer. Let's move on to section D. The region R models the surface of a pond. At all points in R at a distance x from the y-axis, the depth of the water is given by h of x equals 3 minus x. Find the volume of the water in the pond. Now, depth is what I would say is a key word in this one, because now you have to view it as a 3D image, kind of like the square one, but this is a 3D image, so we can infer this can be length times width times depth. Therefore, it's not too difficult. We're going to do this. So we're going to do the h of x, which is given to us, is 3 minus x, times the y1 minus y2, which were our original functions. So length times width times depth, or whatever you want to call it. So, alright, so now we're going to set this up. Also, from 2 to 0, we're going to do 3 minus x sine pi of x minus x cubed minus 4x. dx. Let's stick that back in the calculator. Can I pull off the trick again and reduplicate this one? Just insert 3 minus x, it was 3 minus x. Can we pull it off? Absolutely not. So we'll be right back with the new function. Alrighty, so we're back and it's finally working. So we have 0 to 2. We have 3 minus x times our original top minus bottom. Alright, there we go. And as you see, previously I tested it out and it does come out with the right answer. 8.3699. Alright. And in this case, I think we could it's safe to say we could round up to 370. So this will equal 8.370. And this also is equal to 2 points for the integrand, and then our answer. Alright, the question in total is worth 9 points. And that is AB 2008 FRQ number 1.